Alright, so we have two events, E and F, and we know they're independent. Also, we know the probability of E is 1/3 and the probability of F is 2/5. We need to figure out two conditional probabilities. First, the probability of E given F, and then the probability of F given E. Alright, so let's do the probability of E given F first. So just by the conditional probability formula, this is the probability of E intersect F divided by the probability of F. Alright, now we know that E and F are independent. So that means the probability of their intersection is equal to the product of the probabilities of each of those events. So this is just the probability of E times the probability of F divided by the probability of F. And now look what happens here. As long as the probability of F isn't 0, which it isn't, we can cancel those. So this is just the probability of E. And we know the probability of E is 1/3. Okay, now let's try doing the probability of F given E. So the probability of F given E in a similar way is the probability of F intersect E divided by the probability of E. Again, because E and F are independent, we can write this as a product. And again, just like in the previous example, the probability of E's in the numerator and the denominator can cancel because the probability of E isn't 0. So this is just the probability of F, and we know the probability of F is 2/5. So what can we learn from these two examples? If two events are independent, that means knowledge of one does not affect the probability of the other one. So for example, the probability of E we know is 1/3. If I additionally know that F happened, that still doesn't change the probability of E happening. So F has no bearing on the probability of E, and similarly E has no bearing on the probability of F. And that's what it really means when two events are independent.